I'd like to welcome you and thank you for your participation in today's Water Conservation Town Hall. My name is Steve Jackson, and I'm the Associate Vice Chancellor for Resource Management and Planning, or RMP, and I'm very excited about today's Town Hall, which is the second in our series of Sustainability Town Halls that RMP will be hosting. For today's Town Hall, our focus will be on providing you with background and information on several of our campus programs that are focused on supporting and increasing water conservation, including those within our campus research, our utilities and infrastructure, irrigation management, stormwater management, and many within our green certification programs. For today's town hall, we have a panel of subject matter experts who will be presenting information to you, including our Director of Utilities and Sustainability, John Dilliot, Scripps Institution of Oceanography, Garrett McKirk, who is a hydrology engineer and is part of the Center for Western Weather and Water Extremes, our Energy and Sustainability Manager, Michelle Perez, our Facilities Management, Landscape Construction and Irrigation Superintendent, David Boggs, our Environmental Health and Safety, Environmental Affairs Division Manager, Kimberly O'Connell, our Sustainability Green Programs intern, Josue Gonzalez, and the president of the student group Aquaholics Anonymous, Leslie Naga, and our Sustainability Engagement Manager, Jim Bowser, who will be acting as our moderator for today's town hall and who will be managing the questions and answers at the tail end of today's session. We appreciate your taking the time for joining us today for this town hall, and we look forward to your input, your feedback, and participation going forward. Jen, over to you.
Thank you so much, Steve, and welcome everyone. Before we get started, let's begin with our land acknowledgement. That's the next slide. So UC San Diego community holds great respect for the land and the original people of the area where our campus is located. The university is built on the unceded territory of the Kumeyaay Nation. Today, the Kumeyaay people continue to maintain their political sovereignty and cultural traditions as vital members of the San Diego community. We acknowledge their tremendous contributions to our region and thank them for their stewardship. And again, thank you all for being here today. This is our second Climate and Sustainability Town Hall, the first of which was held on May 31st and focused on our strategic energy plan. The video recording and the Q&A from that session can both be found on our town hall webpage, which is where you probably registered for this one today. Today, we'd like to start by giving you an update on our energy strategic plan. So for that update, I'm going to turn it over to our Director of Utilities and Sustainability, John Dilliot. John has been at UC San Diego for 28 years. In his current role, he manages an annual budget of approximately $100 million, which includes 30 megawatt combined heat and power plant, campus utilities, energy management, purchase utilities, and sustainability carbon management. And John is a Kings Point graduate in marine energy, and marine engineering systems, and a professional mechanical engineer. Welcome, John, to the screen.
All right, next slide, please. Thank you very much, Jen, and thanks for the opportunity here to present. Kind of at the last minute on a project here, and I'll get through it. It's really just an update on potential exciting project using hydrogen as an energy source here. Wait for the slide to come up. So there's a term, green hydrogen, and it really does have a connection to water because green hydrogen is using renewable energy to create hydrogen from water. So really, and then you say, well, what is that connection to the campus energy systems? And on our previous town hall, we really discussed really the energy profile of the campus and how the energy density of our research space really drives our energy use and thus our greenhouse gas usage on campus. And we've looked at hydrogen in the past and really hadn't looked too far into it because, one, if it wasn't created from water, then it had a CO2 component to it from cracking it from a fossil fuel source. But in this current environment, and this picture up here shows this collaboration called the California State Alliance for a Hydrogen Hub called ARCHES, which has it's a California hub that also includes the Office of the President. So there's going to be a UC pathway into getting hydrogen into a potential role in clean energy future. There's $8 billion federal funding that are out there to get this resource into the energy mix. So for the campus, we discussed that 78% of our load is this complex, heavy research space, medical, supercomputing, and research. And of that, we looked at electrification and how that can serve our energy needs. We studied that about 65% of our current comfort heating and water heating loads can be shifted to electrification. But that still leaves about 60% of our campus load that needs to be served by a high density resource, and hydrogen can play a role in that. And the potential project that we were approached to by SDG&E is a hydrogen blending project that would blend maybe up to 20% hydrogen into the California system, not only SDG&E, but the other utilities in the state, which, if proven safe and feasible, could, with the potential to reduce emissions equivalent to about 1.5 million cars off the road. I want to say too, our energy density and how we serve that is so important. We saw that in this September's extended heat wave, where our system was really able to perform on loads that have never really been seen that high, at least here in my 28 years. Next slide, please. So the role that hydrogen could play, it's the simple and most abundant element in the universe, but the ability to generate hydrogen comes from this process called electrolysis, which has been really uneconomical due to the amount of energy and the sort of the round trip efficiency. You put more energy into making hydrogen than the energy you get out of it. But with the federal and state incentives to get the fuel into the system, it's a potential game changer. And say working with them and injecting it into the system from the utility standpoint and getting the price down makes shifting over from fossil fuel, natural gas to hydrogen a real possibility. Next slide, please. And it's really all about safety to doing this. I think everyone, first thing that comes to your mind is of course what could happen with hydrogen and its explosive nature, but blending it into the natural gas system, their studies show that it's a relatively well-known commodity, and it's being used in all over the world. Those areas in the world that don't really have a lot of natural resources, like the UK, Japan, other places in Europe are already doing it. There is this potential of what they call embrittlement of the steel pipes, and that's really what we're looking to study and show that it's safe. The embrittlement issues that might lead to leakage are really happening in the high pressure zones of the natural gas, what they call it transportation portion of it. We'd be looking to do something on the distribution side, at the low pressure side, where the studies show that it is safe, and especially when you're putting it into polyethylene pipe. Go to the next slide. I think we'll wrap it up. The one that there are blending projects blending up to 20% in places in the world. And really, so I'll wrap it up here so we can get on to our next exciting slides here. But the next step really for us is to work with SDG&E and find a pilot project that we can do a pilot to show that it is safe and feasible. Really, it is with the PUC, which is the Public Utilities Commission of California, that have said that all the utilities must perform a real-world test to show that the blending is safe and feasible. And then from that, they can develop tariffs to inject it into the pipelines. So thank you very much for the time, and I look forward to having a follow-up to this later to show what our progress is to date. Thank you very much, Jen. Back to you.
Thank you for the update, John. So we did collect questions in advance, and you are welcome to use the Q&A function. Just please refrain from posting questions to the chat, as it is more difficult for us to track them there. I will note that it is likely our presenters may address some of the questions that have been posed already, but however, we will try to get to as many questions as we can today during the Q&A session at the end, time permitting. Or we may follow up with you directly if we were unable to answer your question live, or the questions will be posted on the new town hall website that I mentioned earlier. So next we have Garrett McGurk, a hydrology engineer at the Center for Western Weather and Water Extremes, also known as CW3E, at Scripps Institution of Oceanography. Garrett has worked at CW3E for 1 year. Prior to it, Garrett worked as a stormwater scientist at a private science and engineering firm here in San Diego. He earned his bachelor's degree in environmental science from UC Santa Barbara and his master's in watershed science from San Diego State University. As a hydrology engineer at CW3E, Garrett is part of a team that manages a network of stream gauges and weather stations located throughout the Western United States. Welcome, Garrett.
Thanks for the introduction, Jen. So now we're going to be taking a step back from campus, and we'll be looking at some projects that CW3E has focused throughout the Western United States. And I'll be focusing on atmospheric rivers and forecast-informed reservoir operations. Next slide. Yep, that one. Perfect. So I work for CW3E here at Scripps Oceanography. Our mission is to provide 21st century water cycle science, technology, education, and outreach to support effective policies and practices that address the impacts of extreme weather and water events on the environment, people, and economy of Western North America. On the right here, you can see 2 of our project locations. Top right is Lake Mendocino in Northern California. Well below its normal reservoir stage. In the bottom right, the Yuba River, also in Northern California at flood stage. So just representing some of our climate challenges we deal with here in California. Next slide. So before I really get into some of the projects we work on, I want to do a quick background on atmospheric rivers. So atmospheric rivers, or ARs as we call them, are relatively long, narrow regions in the atmosphere, essentially rivers in the sky, that transport most of the water vapor outside of the tropics. These columns of vapor move with the weather, carrying an amount of water vapor roughly equivalent to the average flow of water at the mouth of the Mississippi River. When atmospheric rivers make landfall, they often release this water vapor in the form of rain or snow. Atmospheric rivers are responsible for 65% of Western United States extreme rain and snow events. And these extreme weather events caused by ARs are responsible for large-scale flooding, but also extremely important in terms of water resources. To give you an idea of what an atmospheric river looks like, we have a satellite imagery view of a storm producing a landfalling AR on the Pacific West Coast. So you can go ahead and advance that slide. So you can see the way that this storm is pulling moisture out of the tropics and transporting all of that moisture to the West Coast. So where you see all of that focused is where that AR is making landfall, and that's where we see the extreme precipitation from this storm. Next slide. So you know that ARs can cause extreme precipitation events on the US West Coast, but now I want to talk about the role that they play in seasonal variability here on the West. Looking at water year 2019, we can see that most areas where we had landfalling ARs, those arrows in the image, were at or above normal precipitation totals for the season. Advance. So now on the right, we're looking at water year 2022, and we can see that due to a lack of landfalling ARs, most areas were well below average annual precipitation. Advance. So the point I'm making here is a lack of ARs can lead to drought, and they're super important for water resources here in the United States, especially the West. So the interesting thing about that is that until recently, atmospheric rivers had not received a ton of attention in terms of research. So we've seen a lot of research for Western weather, but not around ARs. And with this research, we're seeing that they have a huge impact on water here in the West. So this finding led to the creation of CW3E, the Center for Western Weather and Water Extremes, in 2014. And that was funded through a collection of partnerships with federal, state, and local agencies. Next slide. So one of the ways that we study atmospheric rivers here at CW3E is through our Atmospheric River Reconnaissance Program. So this is a huge effort between CW3E, our partners, and stakeholders. We're collecting observations from a multitude of different platforms. So we have everything from US Air Force C-130s dropping radiosondes, which are essentially a sensor hung by a parachute that we drop from the plane and collect observations as that falls through the atmosphere. We have a NOAA Gulfstream G5 jet that is dropping those from higher up in the atmosphere. We have ocean drifter buoys and observations collected from satellites. Next slide. So in addition to our offshore network of observations that I just talked about, we have our land-based atmospheric river observations platforms as well. So on the left, you can see a soil moisture station that CW3E recently installed in the mountains of Colorado. Top right, you can see a surface meteorology station installed in Northern California. And the bottom right, you can see CW3E launching a weather balloon here at UC San Diego on Scripps Pier to collect weather observations during a storm event. Next slide. So now a little plug for what I do as a hydrology engineer here at CW3E. So my role is focused on quantifying surface water. To do this, I run a network of stream gauges located throughout the West in key areas that we want to know more about what's going on with water availability. These two photos show me working with my field team staff to perform flow measurements at two of our stream gauges in Northern California. The photo on the right there shows one of our stream gauges. So you can see our typical setup with our sensor and our staff gauge. And from those measurements, we're producing stream flow estimates for those bodies of water. So I've talked a little bit about all these observations that we collect offshore and onshore, but how does this actually translate into better management of water resources in the West? So that'll take us to our next slide. So the answer to that, or one of the answers, is forecast-informed reservoir operations, or FIRO, as we call it. FIRO is a management strategy that uses data from watershed monitoring and modern weather and water forecasting to help water managers selectively retain or release water from reservoirs in a manner that reflects current and forecasted conditions. The general idea behind this is that FIRO can be used to safely retain more water than previously allowed to retain in these reservoirs without increasing the risk of flood events due to overtopping. Next slide. So these are the current locations that we have employed FIRO at. Starting from the top, we have Howard Hanson Dam in Washington, Oroville Dam in Northern California, New Bullards Bar Dam in Northern California, Lake Mendocino Dam in Northern California, and Prado Dam here in Southern California. So FIRO has successfully been implemented at Lake Mendocino as our pilot study, and now we're in the process of moving on to these additional reservoirs. Next slide. So now I get to talk about the fun part, FIRO in action, and what this has allowed us to do with these new technologies. So looking at water year 2020, you can see the black line showing additional water savings over the brown line below, which is representing where water levels would have been without FURO. Advance. So this caught the attention of Governor Gavin Newsom, who declared a drought emergency from Lake Mendocino, our project location, and noted that the reservoir held 50% more water than it would have without FURO. Following successful demonstration of FURO at Lake Mendocino, we've moved forward with those additional sites that I referenced in my previous slide, and you can advance this one. And there are our next steps forward for FURO at CW3E. Next slide. So I won't go into all the detail of our operational partnerships here at CW3E, but I wanted to stress that we're not only a research group here at UC San Diego conducting this research and disseminating that to decision makers and scientists, but we have these direct connections with decision makers that allows us to have a huge impact on water in the Western United States. So a lot of really interesting research coming out of CW3E here. This is just the tip of the iceberg. I'd love to talk more about what we have going on, but for today, I wanted to keep it to FURO and atmospheric rivers. If you have any additional questions, you can reach out to our PI, Dr. Marty Ralph, or myself. And if you advance slide, there are the two contacts for myself and Marty. So that's it from me. Thanks for the opportunity to present today.
And thank you so much, Garrett. That was very interesting. I'd now like to introduce Michelle Perez. Michelle has been with UC San Diego in various positions within resource management and planning for over 10 years. Prior to UC San Diego, Michelle was a U.S. Naval officer and science and math teacher. She earned her engineering degree from Northwestern University and is a professional mechanical engineer. As the Utilities and Sustainability Department's Energy and Sustainability Manager, Michelle manages the campus carbon neutrality, energy, and sustainability efforts. Take it away, Michelle.
Thanks, Jen. Thanks to our previous speakers, really illustrates how important research is in developing solutions that we can use and apply today and potentially into the future and beyond. And it shows how important research is in tackling our universal challenges that we face, whether it's climate or water and all together. So thank you so much. And I'm really honored to kick off from the operational side what we're doing at UCSD to create and apply best practices in water conservation and protection. The majority of the rest of the presentations are going to be specific to our La Jolla campus. Many of you know we have a Hillcrest campus. Just wanted to point out many of the things that we're going to talk about today focus on La Jolla, which is significant enough. Our main campus is growing. As we all know, we have 50,000 people in a given day, much construction going on. It's really feels alive, especially with the amphitheater just opening up. John mentioned the energy density. It's very similar with our water. With research, laboratory, clinical, and residential spaces, our spaces are about 2 to 3 times more water intense than an average commercial office building. And on the up to around 1,200 acres that we are on, thankfully, we are able to enjoy beautiful landscape, some of it which is maintained and irrigated. And you'll be hearing from my colleague and how we maintain that space in a responsible and with a conservation mind when it comes to water. Next slide. I want to zoom out just for a bit and kind of remind us all why this is important. You already heard from Garrett, all the tremendous work they're doing, but we're all here today because we all realize the importance of this precious resource, water. It being finite and the implications by not using it responsibly is far and wide, whether it's drought or flooding, as Garrett mentioned. So what we do on our campus is obviously very, very important, not only here, but globally, and it really crosses beyond our boundaries. And we're fortunate to be in a state where we been a part of some leadership in this area. California's leads in environmental issues, and water is no different. And in 2020, in 2009, the then Governor Schwarzenegger passed the 20% reduction by 2020 legislation. And UCOP, Office of the President, furthered that by putting into policy in the sustainable practice policy that the campuses in all locations should reduce by 36% by 2025. I'm happy to say that we've done all that, and we'll talk about kind of the result and looking at the data, and my colleagues will talk about some of the projects that have got us there. It's really important that we do this because where we're at in San Diego, we're at the end of the line. We have water from really three major sources: the Colorado, the Sierra, and even our own basins here from rainwater. It's really important, and putting my energy hat on, that we use our water resources very wisely, not only because of the water itself, but also the embodied energy in that water. Water having to travel so far, there's so much energy that is used to pump, convey, and the treatment of that water. It's really important from not only from the water perspective, but also from the energy perspective as well. Additionally to that, we're using water for washing our clothes or for washing our bodies, and with heating that water, there's additional energy on top of that. So really goes beyond just the water itself. In 2013, and then updated in 2017, we captured all of this this work that we're doing on our campus in our water action plan. You can find this water action plan on our website. And we're really committed to all the projects and all the works that we do in our operations to make sure we maintain responsible water use in our campus and protect the water quality as well. Next slide. And how do we do this? One of the main ways we do this on our campus is by having really good metering. And what we have on campus is a really robust smart metering network. Nearly all campus irrigation and building connections are metered. And what this means is that our folks can have real-time usage data on an hourly interval basis. We can be able to register leaks and identify that and dispatch personnel so we can address those leaks before they become major emergencies. We can also track usage. So if we implemented an efficiency project, we want to make sure we're having sustained success of reducing or maintaining conserved water resources at that location. It also helps us identify where maybe we need some more work. If there's a project that we need to implement and scope out a project, if a building is using more water than we think it should. Next slide. This slide looks at overall water consumption, including recycled and potable water. And you can see when we implemented our water action plan in about 2013, we decided to do a lot of operational and also capital projects that helped us reduce our water use after that. And over the past 5 years, we were able to sustain about a 20% water reduction. On the right, you'll see that we since have converted over to the point where we now are using about 26% recycled water on campus. Next slide. I want to zoom into potable just a bit more. What's really striking here is that with the increased population on campus, with our increased housing, more people on campus, we were able to keep our water use down and potable water use down. Much of this has to do with the infrastructure projects you're going to hear about today in our recycled water, in our irrigation, and also at our central plant. On the right there, you can see the various ways potable water is being used. And this is all attributed to the great work that our metering shop is doing in smart metering and collecting data and being able to really dial into the water use on campus. Next slide. And then finally, I wanted to zoom in even further into just the recycled water and to show how much water we use in the two main ways, in irrigation and our other, with the 73-27 breakdown. What's really important in this is that we're reusing water that would otherwise be treated at the Point Loma wastewater treatment plant and then discharged into the ocean. So by doing this, we're able to use the appropriate water and not having to import more water, which is really good from an energy standpoint as well, since we're not having to import more water for those uses. We're right sizing the treatment for the application that we need on campus. And with that, I'd like to hand it off to my colleagues who are going to go into more detail into some of the really cool projects that we've got on campus.
Thank you, Michelle. Now I'd like to introduce David Boggs. David is our landscape construction and irrigation superintendent and has been with UC San Diego for 4 years. David supervises multiple crews in our landscape services department, including the landscape construction team, irrigation team, street sweepers, and equipment shop mechanics. David holds multiple degrees in horticultural and irrigation and is also a horticultural instructor at Kumeyaay College, where he teaches principles of landscape irrigation and in trees and shrubs and plant identification. David?
Thank you, Jen. Thank you everybody for inviting me here to share some of the things that we do to keep our landscapes sustainable and to conserve water. Next slide, please. Okay, perfect. The conservation of water in the landscape really starts in the design phase. And thankfully, UCSD has sustainability in mind when they design everything. When we're talking landscapes, the design of landscapes comes along with building design and all the developments that we have here at UCSD. So UCSD requires that all new construction projects to be planned, designed, and built as resource efficient facilities. And they follow the leadership in energy and environmental design standards when making these designs. I believe silver is what the minimum is, and we're changing that to LEED gold soon. Part of these standards include water conservation, and that's in the buildings and in the landscape. But more recently, we have been instructed by the state to follow the Model Water Efficiency Landscape Ordinance. This came into effect somewhat like 7 years ago, and this sets water use limitations in the landscape per square foot. And the way that you achieve that water budget that you're assigned based on square footage is by using drought-tolerant plants and efficient irrigation. They do offer some accommodations for turf use in recreational areas because they do know that universities have sports teams and need turf for those sort of things. Next slide, please. One thing when we're talking about low water use plants is you have to make sure that you're selecting something that is climate appropriate. Many people think that San Diego is a desert, and that's not really true. I mean, we do have a desert out to the east, but that's on the other side of the mountains. On this side of the mountains, we are a Mediterranean climate. So there's a difference. In the desert, the rain comes in the summer, but in the Mediterranean climate, the rain comes in the winter. So plants that are adapted to a Mediterranean climate are the plants that we want to select here. There's various areas of the world that have a Mediterranean climate. You have South Africa, Chile, you've got Australia, some areas of Australia, and of course the Mediterranean and South America. So when we're selecting plants, we don't want to just say native plants, because a Northern California native plant is not going to have the same adaptability to our climate as something, say, from the southern tip of South Africa. And when we're designing these landscapes, we want to make sure that we're designing for aesthetics, recreation, relaxation, and physical and mental health benefits, which we'll talk about in a couple more slides. Next slide, please. One of the biggest ways we conserve water here is by irrigating as much of the landscape as we possibly can with recycled water. Recycled water is treated wastewater. It's a 3-stage process that removes solids, clarifies the water, and disinfects it, but it is not drinking water. So it's perfect for our plants and for our central utility plant and our cooling systems, but not in the buildings. So out in the landscape, our total landscape water usage, potable versus recycled, we're at about 45% recycled water use for irrigation. And we do anticipate that to bump up to about 50% or more within the next year as more recycled water areas come online. And we do have a couple of highlights as far as recycled water goes. Is all of our athletic fields, which are the biggest drinkers of water out here, are irrigated with recycled water. We also have the entirety of the La Jolla Medical Center on recycled water, and every new and renovated landscape on campus is going to have recycled water. Great thing about recycled water is we're not using potable water, and also they're not subject to the drought restrictions that are in place. So we can keep things a little more green on the recycled water side. Next slide, please. It's just a little map of the upper area of campus, the sort of the upper campus and east campus areas. The dark purple is areas that are currently irrigated by recycled water. The lighter purple colors are areas where we are pending turnover to recycled water, somewhere within the next 2 to 12 months. We have some areas in light blue here that we have recycled water infrastructure, and we are considering some retrofit projects. And there's a lot of things to consider when it comes to retrofitting areas. We'll talk about that in a sec. You've got sort of salmon color in there, that pinkish color. Those are development projects that will have recycled water. We've got Pepper Canyon West, Triton Center, Theater District, etc. And then the darker blue areas are areas where we do not have recycled water infrastructure, and it would be somewhat difficult to get it there unless there's some sort of development project adjacent. So looking forward in the future, it's certainly a possibility to get recycled water to these areas, but at this given moment, we cannot do that. Next slide. It is difficult to get recycled water where we need it. It comes in a separate pipe, and we have to put those pipes into the ground. And so some of those blue areas you just saw are, islands that we can't really go through the buildings to get these pipes through. You can see some of these pictures here of the larger pipes being installed in the ground and some of the work that goes into getting this put together. The recycled water carries a lot of different building codes and restrictions that govern the installation and use of that water. And one of those things that is most challenging is the need to shut off building water supplies in order to test and ensure that there hasn't been a cross connection, meaning the recycled water has been plumbed to building water. We don't want that to happen. And so that is tested every 4 years. And we have a lot of research going on here at UCSD, and much of that research requires a constant water supply, and we can't risk, we can't risk damaging that research in order to shut the buildings off. So there are things that we can do to install some extra infrastructure to allow for the water to stay on, but of course that takes a lot of effort, a lot of planning, a lot of money to get that stuff put together. So we do look at areas and pick what makes the most sense, and start with the easier projects and then move on to the harder ones. So we are developing the Theater District, Pepper Canyon West, Triton Center. We talked about those. And we do have some retrofit projects that are ongoing right now. Geisel will be converted over to recycled water very soon. And we are currently looking at the School of Medicine for some opportunities to convert there. We do have some infrastructure in place. And finally, there is no recycled water infrastructure in Scripps, unfortunately. That's all city roads out there, and we can't do anything about that. Next slide, please. One thing that we've done in the past where we can't get recycled water is to use artificial turf. This is a picture of Muir Field. In our area of La Jolla, turf grass can use over 22 gallons of water annually per square foot. And so this 100,000 square foot conversion represents over 2 million gallons of water saved annually, which sounds great, but we do tend to try and avoid using artificial turf. There are some maintenance issues and other problems that come along with artificial turf and make turf grass a little better. So especially in areas where we have recycled water, we definitely want to use the regular turf rather than artificial. And our next presenter, Kimberly, she's going to talk about some other areas where we have removed turf and installed some water efficient landscapes. Next slide. We are under drought restrictions. We have been for a very long time. The city of San Diego has had some fairly robust drought restrictions in place for years. And more recently, the state has implemented some that were a little more harsh. And we have been complying with all of them from the beginning. The newest thing from the state is that you shall not irrigate non-functional turf. And non-functional essentially means, do you do something with the turf? Do you play on it? Do you study on it? Do you hold events on it? Or do you just look at it? Is it just ornamental? So the non-functional turf is just the turf that's ornamental. And we've been seeking to remove those areas on campus for many years. Again, Kimberly will talk about some of those areas where we have removed non-functional turf. And we are looking at some other areas, some other smaller projects to remove the few remaining non-functional turf areas of campus. Next slide, please. We make use of efficient irrigation technology. For nearly 2 decades, UCSD has used a system called MaxiCom. It's a central control irrigation system, which allows us to access our irrigation controllers from a single computer and make changes. It can also sense when breaks occur on the system and shut them down when they occur. In the picture here, you can see on the top right picture, those are some flow sensors. The flow sensors send pulses to the controllers. The controllers know how much water should be flowing through the flow sensor at any given time, depending on what's running. And when that flow exceeds what the flow center or what the controller is programmed to monitor, it will shut those off. More recently, we have been moving to a new system called IQ4, and that's what's pictured here on the top left. MaxiCom is pretty old, has a lot of hardware and software limitations, so we're moving to the next generation. Also, we make use of drip irrigation extensively across campus, and in areas where drip irrigation doesn't work, we tend to go for the low volume rotary nozzles, as you can see in the picture in the bottom right. These apply water very slowly, so water doesn't pool up and run off into the landscape. Instead, it will soak into the ground where it belongs. Next slide. So all these things that we go through, all the money we spend, the effort we spend, why go through all of that? And Landscape Services, our mission statement is to maintain an aesthetically pleasing campus, landscape conducive to learning and working. And we do that because it's for all of us here on campus. Studies have shown green spaces lead to improved physical fitness, reduction in depression, social interaction or improved social interaction, stress reduction, improved memory, attention and creativity, and reduced mental fatigue. I think that all of us here on campus, whether we're students, instructors, doctors, staff members, we all benefit from this, from these green spaces, because we all suffer from mental fatigue at the very least, right? So next slide, please. Finally, I would be remiss if I did not give a shout out to my irrigation team. We've got a picture here. I've got 7 people on the irrigation team, but the 7th was just hired. So we get a picture of 6 here. We have Ipacio, Chris, Sergio, Musli, Joe, and Matt. And these guys are great. very experienced team. They manage 300 irrigation controllers. Those controllers run over 6,000 valves. We've got at least 100,000 plus sprinklers out there that we have to fix and maintain, miles of pipe and drip lines. And this is over more than 1,200 acres, because we don't just work here on the central area of campus. We're working in all the remote areas as well, all the real estate and the hospitals and everything else. These guys are highly trained. They do radio programming. They know plants, plant material, plant water requirements. They're doing essentially plumbing, low voltage electrical. They're doing all kinds of things when it comes to maintaining the irrigation system. So I'm very proud to supervise this team, and I hope to continue to do so. That's it from me. Turn it back over to Jen.
Thank you, David. Now I'd like to introduce Kimberly O'Connell. Kimberly has been with the Environment, Health, and Safety Department at UC San Diego for more than 20 years. As the Environmental Affairs Division Manager, Kimberly oversees comprehensive environmental compliance and pollution prevention programs for UC San Diego facilities. Kimberly earned her bachelor's in environmental studies from UC Santa Barbara, and Kimberly is actively involved in implementing creative solutions on campus to conserve water and reduce pollution from urban runoff. Kimberly.
Thank you, Jen. I'm very excited to be here today and to share some recycled water projects that are saving millions of gallons of drinking water each year, as well as water-saving projects that also provide environmental benefits. In response to the drought, UC San Diego expanded the use of recycled water for industrial use in the cooling towers at the Central Utilities Plant. Cooling towers are a major water consumer on campuses with central cooling. The 7 cooling towers at the Central Utilities Plant account for about 25% of water consumption on campus. Prior to this project, the towers used potable water, also known as drinking water, as makeup for cooling processes. This project included bringing recycled water to the cooling towers and upgrading controls and equipment to accommodate recycled water use. The cooling towers now operate using 65% recycled water and 35% potable water, saving more than 60 million gallons of potable water each year. Next slide, please. As a pilot project, UC San Diego has retrofitted the plumbing in selected research buildings on campus to collect air handling unit condensate, reverse osmosis treatment system reject water, and water softener reject water. The collected water goes into holding tanks that are connected to the campus recycled water distribution system. The collected water is then used for irrigation and in the cooling towers, offsetting potable water use. As shown in the table, more than 1.5 million gallons of water are collected each year for reuse in 4 research buildings alone. The amount of water collected during warmer months is high, which corresponds to an increase in need for irrigation water and cooling tower water. By using this water in the cooling towers, the storage capacity for the collected water can be maintained throughout the year. As a result of the successful outcome of these projects, the campus is working to incorporate these collection and reuse systems into the campus design specifications for new research buildings. Next slide. As a follow-up to David's presentation, I'm now going to share some projects that both save water and protect water quality in our watershed. The campus has replaced water-thirsty, non-functional turf with drought-tolerant stormwater treatment landscaping in many locations on campus. In addition to creating beautiful outdoor spaces, these landscaping retrofits save water and improve water quality in urban runoff by removing pollutants. These areas also provide habitat for beneficial insects and animals. Since 2019, approximately 60,000 square feet of ornamental or non-functional turf have been replaced with drought-tolerant landscaping. Next slide. The Ridgewalk Rain Garden, located in the Theater District, is an example of one of these projects. Next slide. Previously, this area was covered in turf that was unused and required a significant amount of water to maintain. Next slide. Now this area includes walking paths and areas to sit and enjoy this beautiful natural oasis. and enjoy the physical and mental benefits that David mentioned. The drought-tolerant landscaping is designed to retain stormwater so it can provide beneficial uses to the plants and attract birds, butterflies, and other wildlife. Next slide, please. Prior to this project, irrigation runoff was a source of wasted water for this area, as well as a source of urban runoff pollution. Next slide. Now, this site is designed to reduce water use and prevent runoff. Next slide. This is another before picture. Next slide. The Ridgewalk Rain Garden also includes educational signs on the many benefits of the drought-tolerant plants and stormwater treatment features that were selected to give people ideas on changes that they can make at home to save water in their landscaping. Next slide. Next slide. At another location, the campus replaced an asphalt road and a turf area with a stormwater treatment detention basin and drought-tolerant landscaping. The white arrow is a point of reference to show the same tree in both locations, or in both pictures. Next slide. By replacing an impervious road with pervious landscaping and a treatment basin, this area can capture stormwater runoff to infiltrate into the ground for beneficial uses. Next slide. Replacing selected areas of pavement and asphalt throughout campus with landscaping where water can infiltrate helps us protect downstream waterways from urban runoff and reduces flooding during high-intensity storms. Next slide. The Grove site also includes educational signs that describe the water conservation, stormwater treatment, and water quality benefits associated with the landscape. Next slide. At another location, a long median with turf between North Torrey Pines Road and Scholars Lane was replaced with drought-tolerant plants and trees, as well as a stormwater treatment swale and basin to treat runoff from Scholars Lane. Next slide. Recycled water was connected to the project site for irrigation, eliminating the use of potable water at this location. Next slide. The landscaped area is designed to capture stormwater runoff from the road during rain, preventing it from leaving the site and removing common stormwater pollutants such as trash, copper and zinc from vehicle brake dust and tire wear, and oil and grease. The next time you're walking through campus, look for landscape features that resemble dry riverbeds. These are designed to slow stormwater runoff down, which prevents erosion, to capture the water for beneficial uses for the surrounding trees and plants, and to remove pollutants in the runoff that it picks up when it flows over paved areas. Now back to Jen.
Thanks so much, Kimberly. Now I'd like to welcome Leslie Na and Josue Gonzalez. Leslie is a senior second-year transfer student majoring in environmental science in the earth science pathway. She is the current president of Aquaholics Anonymous, a coalition between students, staff, and faculty that seeks to send a consistent message of water conservation to the campus community. Josue is a fourth-year environmental systems major and a green programs intern in the Sustainability Programs Office. He is focusing on water conservation as part of his senior internship project. Josue, I'll turn it over to you first.
Hi, Jen. Hi, everyone. Here at UC San Diego, we promote several techniques to save water to those who are on campus and to those who live off campus, such as faculty, staff, and other students. It shows that bathroom water use accounts for up to 70% of indoor residential water consumption. You may not realize it, but flushing the toilet multiple times a day uses more water than showering or washing your clothes. Currently, the federal standard is 1.6 gallons per flush. However, older toilet models can use up to 6 gallons per flush. If you're not in the market to replace your toilet with a low flow model, consider purchasing a toilet tank bank to replace the water or DIY it with a plastic water bottle for water. And if you take a 6-minute shower 7 days a week, you use roughly 4,500 gallons of water per year. Taking just a 5-minute shower reduces annual water use up to approximately 3,800 gallons, saving up to 750 gallons. And you can also reduce your water consumption by turning off the tap when brushing teeth and relathering your hands and body, as well as collecting cold water as the shower heats up. We also encourage saving water when dishwashing. And did you know that dishwashers manufactured on or after May 30th, 2013 cannot exceed 5 gallons of water used per cycle as regulated by the Department of Energy? When using a dishwasher, we recommend scraping off food instead of pre-rinsing, using the normal cycle setting instead of using the heavy cycle setting, running the dishwasher at full capacity, or using the 2 basin method when hand washing dishes. Lastly, one of the biggest ways you can help is to report any instance of a water leak or misuse of water. And you can do that by contacting facilities management, customer relations, and I believe that the slides should be, information should be on a slide. One second. Yeah, there you go. And if you're looking for more tips to learn ways to conserve water, please look at greenerresidence.ucsc.edu. And I'll now pass it over to Leslie. Thank you.
Hi, thank you, Josue. Hi, everyone. My name is Leslie NGO, and I'm this year's president of Aquaholics Anonymous. As Jen mentioned in my bio, Aquaholics Anonymous is a correlation between students, staff, and facility that is space for networking and collaboration between different areas of campus working on water conservation and management projects with a goal to promote water conservation awareness. We are looking for new members to help create and distribute water conservation media and graphics through an official Aquaholics Anonymous Instagram page. Participate in live tabling events to promote public participation in water conservation efforts and collaborate with other water conservation groups on campus. We meet weekly on Friday from 11 to 12 in front of croutons near Yogurt World on Rupert Lane. I would like to extend an invitation to any students who are interested in joining forces to help the environment. Anyone who is interested, please contact me at l4ngo@ucsc.edu or ajloeper@ucsc.edu, and it'll be posted in the chat. Thank you.
Thank you, Josue and Leslie. And sorry that the slides were a little bit delayed. We were just having some Wi-Fi issues. Just happens to be what happens, right? So the last thing that we want to mention is that there are opportunities for you to get involved. And so after the last town hall, and as we will do after this one, we'll be hosting focus groups so that we can get more information from you as our campus community members on the issues that are happening around campus and to hear your ideas. And so we'll be sending out more information about that. And as I mentioned at the beginning, like what we did with the first town hall, we'll be putting the information on our town hall website, which I'm putting in the chat right now. So that's where you can find a recording of this town hall and also the Q&A that we are going to try to address right now, as many as we can, and then also some that we've received from registration and over the Q&A function of today. So without further ado, I'm going to ask for everyone to turn their cameras back on, and we'll hop into the Q&A portion of our town hall for today. Our first question is going to be for Garrett. So Garrett, how are CW3E observations and atmospheric river research utilized outside of the FIRO, the Forecast Informed Reservoir Operations?
Yeah, thanks for the question. That is a fantastic question, actually. So FIRO is just one of the things that we do with all of the observations that we're collecting. So we have this whole network of observations. We're flying the planes, collecting data from those as well. So we do FIRO, managing our reservoirs, but then all of that also translates really well into flood risk mitigation. So we have a whole team of modelers and forecasters that are looking into these storms, and we're looking at how to model long-term water-related infrastructure planning, and we're using climate projections that are accurately representing atmospheric river conditions and other major storms as we move along in time. So there's a lot that we can do with our network other than Bureau.
It's so incredibly interesting. I feel like we could have spent the entire time speaking with you. So our next question is for David. Is it really necessary to separate recycled water instead of just having one water source that includes it?
Yeah, actually, it is necessary. When I was talking earlier about the recycled water not being potable, we can't drink that water, so we can't put it in the same pipe. Recycled water has high levels of chlorine and other salts. And so if you were to drink that, you might become ill. There's also a small chance of some pathogens being remaining within that water. There's a possibility of the single source water happening in the future. I shouldn't say possibility, it's pretty much a guarantee. There's a project that the local water districts are working on in San Diego. It's called the San Diego Pure Water project. And what they're doing is they're taking the recycled water and adding a fourth stage of treatment. And at that point, it becomes safe for drinking. And then they're going to be putting that water back into the reservoirs. I'm not sure when that's supposed to kick off. They've been working on it for quite a while. There is a section of the city of San Diego's website that details that. So for anybody who's interested, they can look that up.
Great, thank you. And Michelle, are we keeping track of how much gray water the campus uses, and where does the gray water go?
Thanks. Gray water, wastewater in our residential buildings and office buildings is referring to the water that's of the waste that we use in our faucets, sinks, showers, but not our toilets. That's black water. We don't have separate systems. We don't meter and monitor our wastewater. All of our wastewater, inclusive of gray and black, all goes eventually to the Point Loma wastewater treatment plant and then is discharged to the ocean.
Thank you. Kimberly, what type of climate adaptation planning or projects related to water are needed considering the challenges of our changing climate?
That's a great question. First, from a planning perspective, the campus is currently looking at updating our climate action plan to incorporate the changes that we need to make and protections we need to put in place structurally for changes specifically down at Scripps Institution of Oceanography, where we may see increases in storm surges, waves, torrential rainfall, to make sure that our facilities at Scripps are protected. And secondly, from a design standards perspective, we make sure that all new development on campus takes those changes in storms, the higher intensity storms into consideration, so that we can put more features like what I discussed earlier around new buildings, so that the stormwater can be retained and reduce downstream flooding.
Thank you. Michelle, we're going to go back to you. We received several questions about toilets. Toilets that flush 3 times after you use them, different types of toilets, and questions about toilets that are in buildings that might not have enough pressure for them to flush properly.
Sure.
Thoughts on toilets?
Yeah, well, everyone uses them. Everyone needs them. Fortunately, we're going to have a plug for our future town halls. We're going to be having a green building town hall and likely in the spring. And they're going to be talking in great detail about the great work they're doing in our plumbing department, amongst many other great things they're doing in our buildings. But for any issues, and it could be different depending on the vintage of the building, whether it's a new building with low flow toilets or if it's an older building having issues flushing. Regardless, if folks are having problems with flushing, they should be contacting our work services center, which in a previous slide, I think we showed, but it easiest is to email wsc@ucsd.edu or give them a call as well.
Thank you. Oh, there's the slide. Garrett, we got a question asking if let's try that again. CW3E offers internships for undergrads.
Yes, we do have an internship program. So I pasted the link in the chat or the Q&A for that, but I will paste it in the general chat as well, so people have that information.
Great. And is there anything you can tell us about the process or what students might get involved in?
Yeah, so typically we have CW3E mentors that will assign interns to, and you'll work on a variety of different projects related to water resources here at CW3E. So that could be everything from joining me in the field or trips to measure water flow to working with hydrologic modelers here studying some of those observations that I talked about. So a wide range of topics and a lot of really great exposure if you're looking to do an internship in water resources.
Wow, that's quite the opportunity. And is there a cycle or can you just apply whenever?
We have a well-defined summer internship program. I think we may also have some opportunities for student workers throughout the year. So definitely can get in contact with us if you'd like to get involved that way. But the summer internship is our primary internship program.
Thank you. Back to Michelle. There was a question in the that was submitted in the Q&A that you would like to address live.
I'm sorry, did you want me to go to Q&A?
Yeah.
There was one, I did answer one related, and feel free, John, to jump in because I know you messaged me saying you'd like to answer. One question that was posed related to the percentage of recycled water in our cooling towers. So our cooling towers are managed very closely, of course. They're very expensive. So we manage the quality of water very closely because recycled water, as already David mentioned, is higher in salts, so it could be really corrosive, and which would be really bad for our cooling towers and would degrade the efficiency of our cooling towers. So that's why we can't upgrade to 100% recycled water in them. John, if you wanted to chime in.
No, I would say that's good. The salts, I mean, it kind of relates to the other question about monitoring the cool water that is being sent out during peak times. So the cooling tower water cools the machines that make the chilled water that go to campus. And in those machines, in the larger machines, there might be 4,000 tubes in the machine in the condenser section of the refrigerant machine. And one tube that gets a leak in it shuts the machine down. So the salts can create scale on the inside of the tubes that can cause them to perform poorly and get leaks, and two, the chlorine, David also mentioned that, causes a higher pH and off gases ammonia as well, and those can be aggressive towards yellow metal. So we monitor those two issues very closely, and 65%. Right now, we've pushed it up to 75. We look at that very closely, and really to finish off with the cool water, the heat wave that we saw in September exceeded the capacity of the plant. Amazingly, if you go over to the Revelle side, you see the construction that's going on over there. We're constructing an expansion of the central plant for new chillers to looking at our load going out 2024 and beyond, and really the load that we saw for days on end, especially during the peak time, like mentioned in the question, that load is what we're planning for in the expansion. That's like a 2026 load that we're seeing. So in the next summer, we're preparing for next summer so we can avoid some of those peak time issues that we saw, maybe with some extra pumping and reducing load in other sections of campus that aren't critical, that aren't in that non-complex space that we talked about.
Well, thank you both for that. And I want to thank you all again for joining us today. We're going to wrap this up so we can try to end on time for you to be able to get to wherever you need to be next. So with our closing remarks, I'll pass it back over to AVC Jackson.
And thanks a lot, Jim. Appreciate that. Yes, just like to thank everyone for joining us today at our Water Conservation Town Hall. As mentioned, we will be inviting folks to participate in our planned feedback focus group sessions that will be scheduled in the upcoming months, and you can sign up to participate through the survey that will be sent out shortly after today's event. If you can't participate, we still want to hear from you, so you will be able to submit your written feedback as an option as part of those surveys. And finally, I'd just like to invite you to join us for our other planned town halls that Michelle mentioned as well, as part of this sustainability series, which will be forthcoming later on in the academic year. So again, thank you, and I hope you all have a great remainder of the day, and take care to all. Goodbye.